Hi, this is Professor Riddell, and we're starting where we left off last time. And today we're going to be talking about acid-base balance. And one of the things you're going to want to do is listen to the YouTube video that I posted a link for because it's really going to help you to understand how to determine what is wrong with your patient based on their arterial blood gases. Okay, so here we are on this slide. We're in the lungs, and in the lungs we have carbon dioxide at a higher concentration in the blood. Therefore, it's going to move into the lungs, and we have oxygen that is in a higher concentration in the lungs, so it's going to move into the blood. Now, remember we talked about this formula here and the actions of carbonic acid, and you can see it moving slowly when it's in the plasma from bicarbonate back to carbonic acid and then over to carbon dioxide and water, which then the carbon dioxide can move out of the blood. And it happens a little bit faster inside of the red blood cells because you have this enzyme called carbonic anhydrase. And so when we get to the lungs, we're able to turn this acid, right, bicarbonate and the hydrogen ions into carbonic acid and then into carbon dioxide and water. So our bicarbonate is what we consider an alkaline reserve of carbonic acid bicarbonate system. So the respiratory system varies carbonic acid, which is a volatile acid, to adjust the pH. So your respiratory system is one of the main parts of your body that is able to change your pH so that we get it and keep it within 7.35 and 7.45. So remember our formula again, we're always going to be keeping this in an equilibrium. And we do this through our ventilation rate. So if our ventilation rate and the little triangle here next to the word ventilation on the second dot, it means delta or change. So the change in our ventilation rate is going to cause a change in our carbon dioxide levels. And the change in our carbon dioxide levels will lead to a change in our carbonic acid levels, and so a change in our hydrogen ion levels. So as carbon dioxide, right, decreases, this formula will shift to the left to create more carbon dioxide, and that will get rid of more hydrogen ions, which will raise the pH level to become more alkaline. So if I hypoventilate, I'm going to have this change in the pressure, right? So hypoventilate means I'm breathing less than normal. It means that the pressure of carbon dioxide is going to increase because I'm not getting rid of it. And therefore, if my carbon dioxide increases, that shifts the formula to the right, which means I have an increase in hydrogen ions. And then this results in a lower pH because that's more acidic. Because more hydrogen ions means more acid means a lower pH. So if I were to hyperventilate, that means breathing too fast, I would get rid of my carbon dioxide, maybe more than I needed to, which means a decrease in my hydrogen ions, driving the reaction towards the left, and this results in a higher pH. And the way that you can help a person that has had this happen, if someone hyperventilates, you usually give them a paper bag to breathe into. And what that does is it helps them to rebreathe some of that carbon dioxide so that it forces it back towards the right, and then it would lower the pH again. So if you have impaired respiration, you could end up with respiratory acidosis from hypoventilation or respiratory alkalosis from hyperventilation. So the second thing that helps us to regulate our pH level is our kidneys. So we have our kidneys that will help us to regulate our pH. So we're going to do this by removing metabolic or aka fixed acids, so phosphoric, lactic, uric acids, and ketone bodies. And by doing that, we remove hydrogen ions and we replenish bicarbonate. So we do lose a bicarbonate is the same, right? Losing a bicarbonate is the same as gaining hydrogen ions. So to excrete excess bicarbonate, the kidney must retain, not secrete, hydrogen. Reabsorbing bicarbonate is the same as losing a hydrogen ion. So when we reabsorb bicarbonate, the kidney must secrete a hydrogen ion. So our urine will become more acidic, and we will save the bicarbonate for use in our in that formula that we looked at earlier. So kidneys also replenish the supply of bicarbonate, normally used up in the extracellular fluid. So bicarbonate is used to buffer hydrogen ions and is lost when CO2 is exhaled. Renal mechanisms of acid-base balance. So reabsorption of bicarbonate. One bicarbonate in the filtrate results in a 1-to-1 return of bicarbonate to the blood. Hydrogen ions are secreted and it ends up as water. We generate new bicarbonate to be added to our alkaline reserve, and this is done via excretion of buffered hydrogen ions in the collection duct. This is important for bicarbonate formation. One phosphate group in the filtrate results in a net gain of bicarbonate in the blood. Hydrogen secretion ends up as H2PO4 via amine secretion in the proximal convoluted tubules. So this is important for excreting acids. 1-glutamine in the proximal convoluted tubule cell results in a net gain of 2 bicarbonates in the blood. Hydrogen ends up in the 2 ammonium ions. So we have secretion of hydrogen and reabsorption of bicarbonate. So as hydrogen ions increase in the extracellular fluid, more carbon dioxide is formed. Carbon dioxide combines with water in the proximal convoluted tubule cells, forming carbonic acid. Carbonic acid dissociates, hydrogen ions are secreted, and bicarbonate is shunted into the capillary blood. Secreted hydrogen ions unites with the bicarbonate to form carbonic acid in the filtrate, which generates carbon dioxide and water. Bicarbonate disappears from the filtrate at the same rate it enters the peritubular capillary blood. This is just showing you the same thing that I just read, but if you look this over closely, it will help you to understand how things are moving um, through from place to place. So the summary is we have 3 mechanisms of acid-base balance. So make sure you remember what these 3 are and what's the description for each. So chemical buffers. So there's a bicarbonate buffer pair in the extracellular fluid. There's a phosphate buffer pair in the intracellular fluid and the urine. And proteins also act as buffers in the intracellular fluid as well in the extracellular fluid. In the respiratory system, this alters carbonic acid, hydrogen ion gains or losses by changing the rate and depth of respiration to eliminate carbon dioxide. In the renal system, this alters the rate of hydrogen ion secretion or absorption and replenishes bicarbonate. This is probably one of the most important slides to remember right here. Okay, now we're going to talk about abnormalities of acid-base balance. So, first of all, a pH greater than 7.45 is considered alkalosis, and a pH less than 7.35 is considered acidosis. A pH of less than 7 or greater than 7.8, you can end up with central nervous system depression, convulsions, and death. So it's very important for our bodies to be maintained at the proper pH. So 4 abnormal conditions exist. So if the problem is in the respiratory system, it's either respiratory acidosis or respiratory alkalosis. And we can determine this by looking at the pressure of carbon dioxide. If the problem is in the kidneys, it's either metabolic acidosis or metabolic alkalosis. And for this, we will look at the bicarbonate readings. Okay, now here's a very important slide for you to remember. So when we look at acidosis, our pH is going to be less than 7.35. And if we're looking at alkalosis, we're looking at a pH of greater than 7.45, right? Anything in between those two numbers and including those two numbers, so if it's 7.35, that's normal, and 7.45 is normal, but greater than that or less than that is abnormal. So then we have carbon dioxide. And so if you'll notice the greater than and less than signs under acidosis, so we have less than 7.35 and we have a less than 22 for the bicarbonate, but it's a greater than 45 for the carbon dioxide. And then between 35 and 45 is normal. Again, that includes both 35 and 45. So if you're having a hard time remembering these numbers, remember that it's 7.35 and this is 35 and 7.45 and then 45 for carbon dioxide. For bicarbonate, you just have to remember that it's 22 to 26. And again, that includes 22 and 26. So if you can draw this little chart right here for the ABGs for acidosis, normal, and alkalosis, including the numbers, this will help you to determine what's going on with the patient. So you can draw for each question in your study guide, draw out I think I actually printed them out for you or added them. So you can make one of these squares and then you just take what the patient's result is and you plug it in where it matches the values up here. So if the pH was 7.30, you would write the pH under acid on the patient results. And then if the carbon dioxide was 46, you would put that right under the acid also. And then say the bicarbonate was 27, so you'd put that in the bottom right corner under base. And that would help you determine whether it was a respiratory problem or a renal problem. And so it's important for you to, at this point, watch the video that I gave you the link to, or you won't understand what I'm talking about at all after this. So either pause this and watch the video if you haven't done so already, and I'll go on. So if for each patient you will choose whether it's acidosis or alkalosis, and whether it's respiratory or metabolic, and whether it's partially compensated or uncompensated. And we know that it's not fully compensated, because if it was fully compensated, then the pH would be normal. Because if there's something wrong with your lungs, your kidneys are going to try to fix it, hopefully. And if there's something wrong with your kidneys, your lungs are going to try to fix it. But when it first happens, it takes a while for it to start fixing it, and that's where you have uncompensated. And so if we put pH and CO2 under acid, and we put bicarbonate under base, then we would know it was partially compensated, because it's trying to fix it, right? Because one is more basic and one is more acid. Now, if my pH is under acid and my CO2 is under acid, but my bicarbonate was normal, that would be uncompensated, because I'm not trying to fix it. Okay, and then we know if it's the problem is with the CO2, if the CO2 and the pH are both together, either under acid or under base, then we know it's respiratory. If the CO2 or the bicarbonate is in the same column as pH, and either under acid or under base, then we would know it was metabolic. Okay, so respiratory system regulates pH via change in carbon dioxide. Make sure at this point you've already gone through and done the study guide questions and watched the whole video from beginning to end of the guide that explains it, and pause and do the problems that he gives you also. Okay, so respiratory system regulation, pH regulates pH via a change in the pressure of carbon dioxide. Thus, we're going to look at the result of carbon dioxide. If the problems lay within the respiratory system, the pressure of carbon dioxide would lie outside of the normal range. So the normal range is 35 millimeters of mercury to 45 millimeters of mercury. So if it's higher than 45, you have acidosis, and if it's lower than 35, you have alkalosis. So respiratory acidosis, this is caused by hypoventilation. So you're breathing very slowly, and your carbon dioxide is building up. You're going to have poor gas exchange via respiratory disease, a decrease in ventilation. So this could be emphysema, pneumonia, or cystic fibrosis. Respiratory alkalosis is caused by hyperventilation, and you have a CO2 reduction. So things that cause this are stress, anxiety, or fear. So the renal system regulates pH via the bicarbonate. Thus, we're going to look at the bicarbonate reading. if the problem lays in the renal system, the bicarbonate would be above or below the normal range. So the normal range for bicarbonate is 22 milliequivalents per liter to 26 milliequivalents per liter. So acidosis would be a bicarbonate of less than 22 milliequivalents per liter. Alkalosis would be a bicarbonate of greater than 26 milliequivalents per liter. Metabolic acidosis. So the cause is a bicarbonate reduction, acid buildup. So things that can cause this are excess alcohol consumption. So alcoholics could have this problem. You could also have loss of bicarbonate via diarrhea. Lactic acid or ketone body buildup can also cause this problem. Metabolic alkalosis. The cause is buildup of bicarbonate or a loss of acid. So something that can cause you to lose acid is vomiting because you have a loss of stomach acid. Overconsumption of antacids. So you can have a problem by taking too many Tums. So Tums or other antacid, the daily ones. You can also end up, if you take too much of these, with B12 deficiency, which can cause you to have a type of anemia that has large red blood cells. So if you have constipation, then your body has more time to absorb more bicarbonate, which again can lead to this alkalosis. So what are the effects of acidosis and alkalosis? So a pH below 6.8, you get depression of the central nervous system, you get coma and death. A pH above 7.8, you get excitation of the nervous system, muscle tetany, extreme nervousness, convulsions, death, often from respiratory arrest. So remember that one system will try to compensate for the other. So if it is a respiratory problem, the renal system will try to compensate by changing bicarbonate. So you'll either reabsorb more bicarbonate or secrete more hydrogen ions. If it's a renal problem, the respiratory system will try to compensate by changing by the depth and rate of ventilation. So an example of compensation. So metabolic acidosis, our blood pH is less than 7.35 and our bicarbonate is less than 22 milliequivalents per liter. So normally the carbon dioxide is between 35 and 45. So excess hydrogen from fixed acid stimulates the medulla and the respiratory rate increases. Hydrogen ions falls as more carbon dioxide is blown off, right? The more you breathe it out, the more you get rid of it. And this will cause the carbon dioxide levels to fall below 30 millimeters of mercury as respiratory system removes the hydrogen via loss of carbon dioxide. So blood values to determine acid-base abnormalities. If you are given the pH, the pressure of carbon dioxide, and the bicarbonate levels, how can you determine which of the 4 acid-base abnormalities a patient has? So first, right, determine whether it's acidosis or alkalosis. That's important. And put it in your little chart. So if it's acids, it's under red. If it's base, it's under green. So then I want to look at each of the carbon dioxide and bicarbonate. And so if the bicarbonate is more than 45, it goes on the acid side. If it is less than 35, it goes on the base side. And if it's not, it goes in the middle. And the bicarbonate, again, if it's acid, it's less than 22, and if it's base, it's greater than 26. And once you have put them into the table, you can say which one is matched with the pH. So if carbon dioxide is matched with the pH, that's a respiratory problem. If the bicarbonate is matched with the pH, then it's a metabolic problem. So once we've determined whether it's respiratory or metabolic, and we've determined whether it's acidosis or alkalosis, the next thing we have to do is determine if it's compensated, partially compensated, or uncompensated. So if it's partially compensated, that means that if the pH and the carbon dioxide are under acid, then the bicarbonate would be under base. So that would be partially compensated. So it's at the opposite end of the table. If the pH and carbon dioxide are in acid and the bicarbonate is normal, that is uncompensated. So it shows you respiratory acidosis. So respiratory acidosis, the pH is low, right? Below 7.35. The carbon dioxide is greater than 45. And if you're compensating with your kidneys, then your bicarbonate is going to be above 26. If we have respiratory alkalosis, our pH is above 7.45. Our carbon dioxide is less than 35, and our bicarbonate is less than 22. If it's metabolic acidosis, the pH is below 7.35. Our carbon dioxide, if compensating, is less than 35, and our bicarbonate is less than 22. If it's metabolic alkalosis, the pH is above 7.45. If compensating, the CO2 is greater than 45 and the bicarbonate is greater than 26. So if you watch the other video and you still didn't get it using that nifty little chart, but you could memorize this table and draw this out, then you could also determine which one it is. So remember that if it's one problem, see where it says if compensating, if it's uncompensated, then it would be in the normal range. And again, if the bicarbonate was not compensating, it would be between 22 and 26. And if the carbon dioxide is not, if the lungs aren't compensating, then it would be between 35 and 45.